All right, so carbon compounds form structures of whale cells and control reactions that take place in those cells. The instructions for these processes are stored in organic compounds. So an organic compound, by definition, contains carbon and hydrogen. You'll hear a lot about organic carbon and hydrogen, often combined with a few other elements such as oxygen and nitrogen. Those are the four fundamental things for life on Earth. The majority of you guys are carbon, hydrogen, oxygen, and nitrogen. There are millions of organic compounds, more than 90% of all known compounds. So what they're saying is 90% of the stuff that we know is organic. 90% of the stuff that we know and we're aware of has carbon and hydrogen in it. Carbon has 4 valence electrons. A carbon atom can form 4 single covalent bonds, a double bond with 2 single bonds, or a triple bond and a single bond. Carbon, because it has 4 valence electrons, is probably one of the more versatile atoms. Now, silicon is in the same group, also has 4 valence electrons, but carbon is the lowest tier, has the lowest number of protons, lowest number of electrons total. So it's very versatile. That's why it's in so much stuff. Same with hydrogen, 1 proton, 1 electron, 1 valence electron. So hydrogen can interact with a lot of stuff too. Most of the bonds in organic compounds are carbon to carbon bonds or carbon to hydrogen bonds. Sugar, carbon, hydrogen. Any organic material you could think of, fossil fuels, carbon and hydrogen. Most living things, well, if not all living things on Earth, are carbon and hydrogen, or organic. So, what are 3 forms of carbon? Well, diamond, graphite, and fullerenes are forms of carbon. So, a diamond, you guys know what a diamond is, but it's an example of a network solid in which all atoms are linked by covalent bonds. Covalent bonds connect each carbon atom to 4 other carbon atoms. A 3-dimensional structure is rigid, compact, and strong. Diamond is harder than any other substance because cutting a diamond requires the breaking of covalent bonds. Diamonds take thousands of years of pressure that forces these bonds between the carbon atoms. The fake diamonds are basically them taking carbon atoms or a carbon material and putting a lot of pressure on it. Graphite is extremely soft and slippery. It's like what's in your pencil lead. Carbon atoms are arranged in widely spaced layers. Within each layer, carbon atoms have strong covalent bonds with 3 other carbon atoms. Between the layers, the bonds are weak and the layers slide off. That's why they're great for pencils. Like when you write, you're literally writing a layer of carbon on the paper with a pencil. Fullerenes are large hollowed spaces or cages of carbon. On the surface of a 60 carbon fullerene, or C60, the atoms form alternating hexagons and pentagons. That's just based on the way that the carbon atoms structure themselves. We don't dive that deep in ICP, but if you take a regular chemistry class, well, maybe more of a college level chemistry class, we'll talk about lattice structures, and that's just how the atoms arrange themselves based on bonds and stuff like that. But anyways, these are referred to as fullerenes. So in a diamond, carbon atoms are arranged in a rigid 3-dimensional network. So this is what a diamond looks like. Graphite is not so much 3-dimensional, but rather 2-dimensional. So you have one layer here and another layer here. Now, the fullerenes are kind of like this, okay? They're hollow spheres that are kind of connected together. What factors determine the properties of a hydrocarbon? A hydrocarbon is an organic compound that contains the elements of hydrogen and carbon. Factors that determine the property of hydrocarbon are the number of carbon atoms and how the atoms are arranged. A saturated hydrocarbon in a saturated hydrocarbon, all of the bonds are single bonds. A saturated hydrocarbon, hydrocarbon contains the maximum number of hydrogen atoms for each carbon atom. Saturated hydrocarbons are called alkynes, and they end with A-N-E. Okay, this is going to be on your reading guide, so pay attention. All right, we're going to ask you what is a saturated hydrocarbon and what is an unsaturated. So a hydrocarbon molecule can contain one carbon atom, as in methane, or 30 carbon atoms, as in asphalt. Carbon atoms can be arranged in a straight chain, a branched chain, or a ring. Microorganisms in the stomach of a cow produce more than 500 liters of methane gas per day. So that's just the molecule for methane is one carbon atom to 4 hydrogen. This should be subscript. Somehow it didn't translate. Dairy farms are the largest contributor to greenhouse gases on planet Earth. There's not, you would think that cars contribute more greenhouse gases. No, it's the dairy farms. So straight chains. A molecular formula shows the type of number of atoms in a molecule of a compound. The structural formula shows how these atoms are arranged. The boiling point of a straight chain alkane depends on the number of carbon atoms. Methane, propane are gases at room temperature. Pentane and octane are liquids. So I should probably state that when we're talking about alkanes, they end in ane, propane, methane, octane. These are all items that are saturated hydrocarbons. Okay, octane. I don't know if you're aware of this, but in petroleum they give an octane reading. So just keep that in mind. So let's look at what this looks like. So methane is just a really basic carbon-hydrogen arrangement. Propane, it seems like you chain a couple of methanes together. It's a longer chain. Pentane, now where this comes from is you have one carbon here in the center. Here you have 3. Pentane, how many do you think you have? 5. And then octane, guess how many you have? 8 carbons. Okay. Now, as you increase the carbons, look at the boiling point. The boiling point for methane is way down here because it's a gas at room temperature. The boiling point for propane, same thing, way down here because it's a gas at room temperature. This is a liquid, this is a liquid. So, branch change. Butane and isobutane have a molecular formula, C4H10, but their structural formulas are different. So, this is the same with regards to the number of carbon per hydrogen, but how they're actually arranged, right? Remember that isotopes are the same atoms, but a different configuration. Same thing with butane and isobutane, okay? So compounds with the same molecular formula, but different structural formulas are isomers. So those are isomers. Okay. And isobutane, there is a branch at the point where the carbon atom bonds with 3 other carbon atoms. The differences in the structure affect the properties of the isomers. Butane boils at negative 0.5 degrees Celsius, while isobutane boils at negative 11.7 degrees Celsius. Here's another isomer and saturated hydrocarbon. Rings are something that you could see sometimes. So carbon atoms like cyclobutane are linked in a 4-carbon ring. So it's the same formula sort of, except this has less hydrogen obviously, but this is a ring. So in a cycloalkyne, the carbon atoms form bonds with 2 other carbon atoms and 2 other hydrogen atoms. So the cyclobutane molecules have 2 fewer hydrogen atoms than butane. Most ring alkynes are cyclic hydrocarbons, which have rings of 5 or 6 carbons. So cyclic just means like circle, cycle, ring. What are the 3 types of unsaturated hydrocarbons? A hydrocarbon that contains 1 or more double or triple bonds is an unsaturated hydrocarbon. There are 3 types of unsaturated hydrocarbons: alkenes, alkynes, and aromatic hydrocarbons. So ethene is a different one. This is where you think of like ethanol, okay? But a double bond between the 2 carbons is what makes this, it ends in the ene. You have a double bond here. It's C2H4. Many fruit-bearing plants have ethene in it, C2H4, which controls the rate at which the fruits, such as a tomato, ripens. Alkynes has a triple bond, right? So alkynes are straight or branched chain hydrocarbons that have 1 or more triple bonds. So when you think about some of these names, actually ethanol is closer to the, anyways, I'm sorry. So it's the bonds. Alkynes are the most reactive hydrocarbons. Ethine is known as acetylene, like acetylene torches. Aromatic hydrocarbons. Benzene is known a lot because of its ring, but it's also, these are called benzene rings, but there's 3 double bonds, and it's in a ring structure. Although the formula for benzene shows an alternating single/double bond, the 6 bonds in the ring are identical. All 6 carbons share 6 of the valence electrons. Hydrocarbons that contain similar ring structures are known as aromatic hydrocarbons. The name was chosen because many of these compounds have strong aromas or odors. Odors, not orders. Can't talk today. What are the 3 main fossil fuels? Well, the 3 main ones are coal, natural gas, and petroleum. The majority of energy consumed in the world is somehow produced by coal, natural gas, or petroleum. Coal. And they're all made the same way. You'll see as we go through it. Coal. Giant tree ferns and other plants were buried in swamps. Over millions of years of pressure, the plant remains produced a mixture of hydrocarbons. Most of the hydrocarbons in coal are aromatic hydrocarbons with the high molar masses. Coal produces more soot than any other fossil fuel. Now I want to talk about what soot is. Soot is the dark smoke. So if we're used to thinking of soot as something that you see in a chimney, but it's the dark smoke. The dark layer that's in a chimney that we refer to as soot is the very fine particles that are produced through the combustion of hydrocarbons or fossil fuels. Now, charcoal produces the most soot because it doesn't burn clean. As we move through these, some of these burn cleaner than others. Now what that means is the carbon is left over. Soot has carbon in it. On some of these, when it does the oxidation or combustion process, all of the materials are used up. But with coal, there's a little bit of carbon that remains, okay? And we call it soot. Ferns such as these that lived millions of years ago basically over time die. They get buried under dirt and other swamp and organic materials. There's a lot of pressure because of the weight of the stuff on top of them, and it eventually hardens and turns into coal. Natural gas is formed by the remains of marine organisms. The main component of natural gas is methane. Natural gas also contains ethane, propane, and isomers of butane. Natural gas is used for heating and cooking. We love to use natural gas inside the house because of the chemical and molecular structure. It burns clean. When you burn methane, the byproduct, when it combines with the oxygen, is carbon dioxide. Almost all the carbon is used up to make carbon dioxide. And then the hydrogen and oxygen, remember that when you burn things, it combines with oxygen. So this is a hydrocarbon. So the hydrogen burns with oxygen to form water vapor. So when you burn natural gas in your house, it creates two things: carbon dioxide, which is okay for humans, and water. That's the byproducts. Almost no soot. Okay. Deposits of natural gas are found along with coal and petroleum. So these fossil fuels are kind of in big clusters. Wherever there was life millions of years ago, over time they decompose and become fossil fuels. Petroleum is formed by marine organisms. Petroleum is pumped from deep beneath the Earth's surface. Petroleum is a complex liquid mixture of hydrocarbons, mainly long-branch alkynes and alkenes. Petroleum is separated into mixtures called fractions. So when basically if you take crude oil and you heat the oil up, the different levels of vapors are the different products. Gasoline is a vapor that cools from petroleum. Petroleum jelly is the very bottom tier. Way towards the top is stuff like paint thinner and mineral spirits. Okay, they're just different filtrations or levels, and it's all done through a distillation tower. They basically boil it, and the vapors are collected at different levels. The vapors that are the thinnest and make it all the way up to the top are the thinner materials like mineral spirits or paint thinner, if you want to think of it that way. The one towards the bottom are very low, like actual oil that you put in your car. Petroleum jelly is kind of a byproduct of making gasoline. So basically you heat up the crude oil, and the very bottom tier is asphalt. That's the thick sludge. The next thing would be like a lubricating oil like you put in your car. The next layer would be a heating oil like a diesel fuel. On top of that would be kerosene, which is also used for jet fuel. Then gasoline that you burn in your car. Also notice that it's based on the temperature. As it starts to cool, the vapor will go higher. And then petroleum gas is towards the top. Okay. What are two primary products of the combustion of fossil fuels? Well, here's the issue. When you burn a fossil fuel, you're going to get a lot of carbon dioxide, which is okay. You're going to get a lot of water, too. Those are the primary one. But there's an incomplete combustion, too, that occurs. So if not everything is used up, then you get carbon monoxide. Carbon monoxide is not good for human beings. We breathe it in and we have a hard time getting it out. It's not good for us. Okay, it's not good for the environment either. Sulfur dioxide and nitrogen oxides released into the atmosphere by the combustion of fossil fuels form sulfuric acid and nitric acid. When it rains, then remember, were you guys taught in elementary school about acid rain? Acid rain occurs when you burn fossil fuels. Fossil fuels will release these acids in very small molecules, and they float in the air. When it rains, the water comes down through the air and collects the acid. Over time, that acid rain will basically deteriorate things like stone, metal, concrete, and it's not good for us. Okay, that's why it's so important to try not to use a lot of fossil fuels and release these harmful gases. So real quick, graphite is soft and slippery because its carbon atoms are arranged in layers. Okay? In general, the boiling point of a hydrocarbon increases as the number of carbon atoms in the chain increases. An unsaturated hydrocarbon always contains at least one double or triple bond. A hydrocarbon in which two of the carbon atoms are joined by a triple bond is, anybody remember what that one's called? It's got to have at least one triple covalent bond. It's D. Oh, no, it was C. I'm thinking D is the ring, okay? Most hydrocarbon compounds in coal are aromatic hydrocarbons. Those are the ones that have the rings. My bad. Which of the following compounds is formed during the combustion of fossil fuels and then reacts with water in the air to form acid rain? B. Sulfur dioxide. Carbon forms the backbone structure of millions of different organic compounds because each carbon atom forms 4 covalent bonds with other atoms. True. 4 is the magic number. A compound that is an indicator of incomplete combustion hydrocarbons is carbon dioxide. False, it's carbon monoxide. And that's it. Any questions for Mr. Adams?